This is 11.3 part 2, and we're going to convert equations. So just like converting coordinates, there's an easy direction and then a direction that requires a little more thought. Let's do the easy direction first. When we're going from rectangular to polar, everywhere we see an x, we put in an r cos theta, and everywhere we see a y, we put in an r sine theta, and then we're good to go. So there's really very little thought required. So on this one, we've got r sine theta equals r squared cosine squared theta. And now we want to solve for r. So I'm actually going to divide both sides by r, which is not something you see me do a lot. Usually I say never divide an equation by a variable. Sine theta is r cosine squared theta. In the case of polar coordinates, it's usually very safe to divide both sides by r. In fact, it's necessary. And you won't lose any solutions when you do that. So you feel free to divide both sides by r. So now we're going to solve for r. So r is sine theta over cosine squared theta. And you can leave it like that, that's fine. Or you could write it as tangent theta, secant theta. Either or. Okay, next one. This is a circle of radius 3, because r is 3, centered at 0, 3. So let's see what that turns out to be in polar coordinates. R squared cosine squared theta plus, I replace y with r sine theta. Square that, and that's 9. Okay, I need to FOIL out this binomial, r squared cosine squared theta plus r squared sine squared theta minus 6r sine theta plus 9 equals 9. Okay, I see an r squared cosine squared plus r squared sine squared. That's just going to be r squared. I'll just show you why. This is cosine squared theta plus sine squared theta. But cosine squared plus sine squared is 1. All right, minus 6r sine theta equals 0. Subtract 9 from both sides. So now we have r squared minus 6r. Well, I'm going to leave the r squared here and move the 6r sine theta to the other side and divide by r. R is 6 sine theta. So that's a much nicer equation than the one we started with. Typically circles have very nice equations in polar coordinates. Let me just graph that for you. That's a circle, because we'll come back to this when we do polar graphs. This is a circle of radius 3 centered at x equals 0, y equals 3. So it looks like that. And it crosses the y-axis at 6. Okay, so now let's go in the other direction. This is the direction that requires a little bit more thought, because you can't just plug in. What you have to do is look for expressions like this. Because if you see an r squared, you can put in x squared plus y squared. If you see an r cos theta, you can put in an x. R sine theta, put in a y, etc. So this is going to require some manipulation. R equals 2. Well, first of all, I know that this is a circle of radius 2 centered at the origin, because it's the points that are 2 units away from the origin. Okay, but how am I going to get that using this method? Well, square both sides of this equation. And now we see we have an r squared. You can replace the r squared with x squared plus y squared. And as I promised, that's a circle centered at the origin, radius 2. Okay, theta is pi over 3. Well, if I had a tangent in front of that theta, I could replace it with y over x. So I want a tangent there, so I'm going to put one there. Tangent theta, but whatever I do to that side, I have to do the same thing to the other side. equals tangent of pi over 3. Now I can replace the tangent theta with y over x, and tangent of pi over 3 is root 3. So this is the line y equals root 3 times x. Okay, r equals secant theta. So this is an important one. Whenever we see r equals a secant theta, that's going to be the vertical line x equals a. And whenever we see r equals a cosecant theta, that will be the line y equals a. Here's how I'm getting that. Secant is 1 over cosine. So let's multiply both sides of this equation by cosine. R cos theta is 1. All right, well, I can, every time I see an r cos theta, I can replace it with an x. So x is 1. So in this case, this is the case over here where a is equal to 1. Okay, and last one before I have you try some. R is 2 cos theta. Okay, so let's see. If I square both sides, I'll have a nightmare. I'll have x squared plus y squared over here, but over here I'll have cosine squared with no r's. That would be bad. I think the most useful thing to do here is multiply both sides by r. So then I get my r squared on the left, but I get a 2r cos theta on the right, which is perfect because r cos theta is x. So the left is x squared plus y squared, and the right is 2x. Okay, that's x squared minus 2x plus y squared is 0. This is actually a circle. Let me show you why. We need to complete the square on this, and so this can be written as x minus 1 squared. But x minus 1 squared is x squared minus 2x plus 1. So I need to subtract 1, and then plus y squared is 0. Now move the 1 to the other side. X minus 1 squared plus y squared is 1. That's a circle of radius 1 centered at 1, 0. So it looks like that, and it crosses the x-axis at 2. All right, now pause the video and you try these next two. All right, hopefully you did that. Convert to polar and solve. So this is the easy direction. Just wherever you see an x, you replace the x with r cos theta. There are no y's, so r cos theta is 5. And now solve for r. R is 5 secant theta. We kind of knew that though, because I said up here, if you see r is a secant theta, that's the vertical line x equals a. But we were going the other direction. We had x equals 5, and we converted it to polar. All right? Convert the next one to Cartesian. Whenever you see Cartesian, that just means rectangular. They're synonyms. Okay, so I think we should multiply both sides by sine. R sine theta is 2. Y is 2. Okay, and then we'll finish up this section with one more video. It's probably going to be the most challenging. And so I'm going to pause it for now.